Okay, question 24, the last question. It's a vectors question. It tells me A, B, C, D is a parallelogram. This is important because I know that B to C is the same length as O to A and it's parallel. So this vector is also A because it's the same as this one. And I also know that AC is the same as OB. So same length, same direction. This vector here is the same as this vector at the bottom here. So this is a B. I'm just going to draw that on my diagram. It might help me. OA is OA from O to A is the vector A. That's fine. And OB is the vector B. So from O to B, that's the vector B. They're on my diagram. I don't really care about these. D is the point such that AC, D is the point such that AC equals CD. Okay, so if that's D is the point so that AC equals CD, then if they're the same, then this one must also be B. This one must be the same as this one here. Okay, so I've used that information. I can scribble that out as well. I don't care about that anymore. It then says the point N divides the line AB in the ratio 2 to 1. And what I really need to do is convert this ratio to a fraction. So if I just create a little box, here you go. Here I've got some squares that are shaded in the ratio 2 to 1. This is 2/3 and this is 1/3. What that means is that the line AN is 2/3 of the line AB. And the line NB is 2/3 of the line AB. Sorry, 1/3. So this bit is 2/3. This bit is 1/3 of this line AB. Okay, I've got to write an expression for ON. So I'm going to draw that on my paper. I've put an arrow on there because I've got to go from O to N. From O to N. And there's two ways I could do it. I could either go from O to B and then from B to N, or I could go from O to A and then come down from A to N. Either of these is fine. I know that this is 2/3 and this is 1/3 of the line AB. So I'm going to have to use this line AB to get to N. So I'm going to find out what the line AB is first. So to get from the line to get the line AB, I've got to go from start at A because it says I'm starting at A. I've got to go from A to O, from A to O, and then I'm going to add from O to B. So now I've written in capitals, I can use these little letters, A's and B's. A to O is a minus A. It's minus because it's in the opposite direction to the arrow. O to B is a plus. It's the same direction as the arrow, so it's a plus B. So this is my line AB. If I want to find what ON is, I'm going to go up to A and then down to N. So I'm going to go from O to A and then I'm going to go from A to N. From O to A, it's the length of vector A, it's the direction of vector A, so it's just A. And then I'm going to add to that AN. AN is 2/3 of AB. So that is 2/3 of AB. So that is equal to A plus 2/3 of AB, which I've worked out here, minus A plus B. And what I have to do is, or what I should do, is write that in simplest form. And to get all 3 marks, I'd have to collect terms and write that in simplest form. So I'm going to expand this bracket. So A, and this is minus 2/3 of A, and this bit here is plus 2/3 of B. And now I can collect these terms together. Whole A minus 2/3 of A is 1/3 of A, and then I've still got 2/3 of B. Often in these vector questions it's good to factorise these answers. In nearly all cases the first part is used in the second part. So I'm going to factorise this. It's got a factor of 1/3, and I've got A plus 2B over here. Okay, the second part of the question, again, it's a starred question here. I've got to prove that OND is a straight line. So if I carry on, I go to my diagram, carry this on, I've got to prove that this is a straight line. And to prove it's a straight line, I've got to prove that the vector ON is parallel to the vector OD, and it will be a straight line then because they share the point O. Or I've got to prove that ON is equal to ND, or a multiple of it, and then there'll be a straight line because they share the point N. Either way is fine. I think it's easiest to find out what OD is, prove that they're one multiple of another, and then it's a straight line because they share point O. So I can say that OD is equal to OA plus AC plus CD, and OA is an A, and AC is a B, and CD is a B, and if I collect the terms I get A plus 2B. And here you see the benefit of factorising, because here I factorise and see it's a multiple of A plus 2B as well. So I can say ON is equal to 1/3 A plus 2B. So now I've used the maths to prove that they are a straight line. They are a multiple of the vector A plus 2B. They are both multiples of it, and they share the point O. So that's why they're a straight line. What I've got to do is say that in words. OND is a straight line because ON, I should write a vector here, and OD are both multiples of the vector A plus 2B, and they share the point